And here we are looking at 1.5, page 2. We're looking at this unique operation called composition. So you can't do this with just regular numbers, you have to have functions. And notice it's not a little dot, it's a circle. So this is not f times g of x, this is called f of g of x. In other words, we're taking the g of x and we're plugging it inside f of x, like if we were to find f of 3. Okay, so this is read f of g of x. This is not multiplication. The domain here is a little interesting. The final domain depends on the domain of g of x, the one you're plugging in, and the composition to see how the domain of f is affected when we plug the g into f. So those are the two things we worry about: the domain of what we're plugging in and the domain of the final outcome. All right, so A, f of g of x. Well, f of x, we have the square root of x plus 3, which has a domain of x is greater than or equal to negative 3. We have g of x equals 2x squared, which is just all real numbers. So we're going to find the composition and we're going to find the domain of the composition. So here, f is the square root of something plus 3. And the something we're plugging in is g, so I get the square root of 2x squared plus 3. And nothing here can be reduced, so that's our answer. We first look at what was plugged in. G is all real numbers, but now we look at the outcome. We know this thing has to be positive. So 2x squared plus 3 is greater than or equal to 0. 2x squared is greater than or equal to negative 3. X squared is greater than or equal to negative 3 halves. Well, that's always true. When you square something, it automatically becomes positive unless it's 0. So that's always going to be greater than a positive number. So g is all real numbers, this is all real numbers, so our domain is all real numbers. All right, so g of f of x, well, that means g is 2 times something squared. Well, the something we're plugging in is f of x, so I get 2 times the square root of x plus 3 squared. So here the square and the square root cancel, so I get 2 times x plus 3. I distribute and get 2x plus 6. So the original f that we plugged in, the domain is x is greater than or equal to negative 3. 2x plus 6 is just a linear function which has a domain of all real numbers, so the f is going to restrict our domain. So our domain is all real numbers such that x is greater than or equal to negative 3. All right, so let's try this with two new ones. So we have f and g, 2x minus 4 and x plus 5. Both of these have domains that are all real numbers. So I'm going to find f of g of x. So f is 2 times something minus 4. The something we're plugging in is g, which is x plus 5. And I'm just going to distribute the 2 and then combine like terms, and I get 2x plus 6. So the original g we plugged in has a domain that's all real numbers. 2x plus 6 has a domain that's all real numbers. So our final domain is all real numbers. All right, so here, g of x. So g is something plus 5. And the something we're plugging in is g. So I plug in x plus 5, combine like terms, and I get x plus 10. What we plug in is g, so the original domain is all real numbers. X plus 10 has a domain of all real numbers, so our final domain is all real numbers. And that finishes up page 2 for ya.